Machine learning, exploring unsupervised learning. So today we're going to be talking about machine learning. So what's machine learning, if you may ask? So this is a powerful tool that allows computers to learn from data and make predictions without being explicitly programmed. Meaning computers learn from what past or historical data that let's say you had typed in or imputed once back way back and give you decisions based on that data. So today what we're going to do is we're going to dive into one of the most widely talked about or used type of ML, which is supervised learning. So what is supervised learning? So in supervised learning, there are like three aspects that we talk about mainly. Okay, number one is labeled datasets. So in supervised learning, the algorithm is trained on a labeled dataset where the desired outputs are known. Number two is mapping inputs to outputs. So the algorithm learns the map input, features to their corresponding output labels, creating a predictive model. So what it does is that it learns how you map, let's say, letter A to letter B in order to create like a relationship between these two. So thus creating a predictive model. Number three is predicting new data. So once these relationships have been established, let's say from A to B, from boy to girl, from cat to dog, then one string, the model can now be used to make predictions on new and unseen data. So now we're going to talk about the applications of supervised learning. So classification. So what classification talks about is it determines the category or class of an input, so such as spam detection, image recognition, and medical diagnosis. Regression. So what regression is talking about is predicting a continuous numerical output like house prices, stock market trends, or energy consumption. Now, last but not least, forecasting. So what does forecasting mean? It uses historical data to make predictions about the future, such as weather forecasting, sales prediction, or customer churn. That is the amount of customers that you get within a given period of time. So label data sets and features. So what are the features of this label of data sets? Number one, input features. So the relevant characteristics or variables that describe the input data, such as age, income, of product features. So let's say features, or let's say you want to describe a data set talking about animals now. So if you want to classify what is a mammal, what is a land animal, sorry, and an aquatic animal. So you cannot say, okay, the input features, okay, these aquatic animals have fins, gills, while land animals have noses for respiration. Mhm. So now we have output labels, which is desired target values or outcomes that the model is trying to predict, like loan approval or customer satisfaction. Then third is data quality, which is the accuracy, completeness, and relevance of the label data sets that is crucial for the model's performance. So we are not meant to be prone to errors when labeling our data sets. It's meant to be of the highest standard or integrity. Now, last is feature engineering. Selecting and transforming the input features can significantly improve the model's predictive power. So, training the model. What we first do, how we train models now is first we come and split the data. So, this data set is divided into training, validation, and test sets to evaluate the model's performance. Model selection, choosing the appropriate algorithm such as linear regression, decision trees, or neural networks. Then hyperparameter tuning. So what that means is adjusting the model's parameters to optimize its performance on the validation sets. So making predictions, new data. So now the trained model can be used to make predictions of new and unseen data, make let's say inferences or rightly said predictions to be able to tell you, okay, September, let's say for weather forecasting of September is going to be really rainy or it is going to be really cold during September because of the historical data and able to like collect from past data sets. Predicted outputs. The model outputs the predicted label or values based on input features and then model accuracy. The model's performance is evaluated based on metrics like accuracy, precision, and recall. Evaluating model performance. So how we evaluate models are using these four criterions. Accuracy. The proportion of correct predictions made by the model. Precision. The ratio of true positive predictions to total positive predictions. Recall. The ratio of true positive predictions to all actual positive instances. And then the F1 score. This is like the homogenic mean of precision and recall, providing a balanced metric. The deviation. So conclusion and key takeaways from this project. So supervised learning now, from what we've been able to gather from the class or the video is an algorithm or algorithms learn how to map inputs to outputs using label training data. Okay, now the applications, classification, regression, and forecasting are common use cases. And number three, model evaluation, accuracy, precision, recall, and F1 score are important performance metric. So supervised learning is a really, really important tool and powerful tool for making predictions. Now in this age of AI, concepts like this are really, really interested, are really pioneers or front runners for new advances in AI. So what supervised learning, what we learn from supervised learning is that it's a tool, a very powerful tool used for making predictions and decisions based on data. So by understanding its key concepts and applications, we can unlock the potential of machine learning in various domains. Thank you.